This is not vinyl. It looks like a record because it is one. As a matter of fact, it's the record. Before any vinyl LP can exist, a master needs to be literally cut. And this is just that, a lacquer cut. It can be played on any turntable, but unless you're in the business or play a master cut record from Supersense, there's really no easy way to experience just how incredible one sounds. Which led to an idea I don't think anyone else has ever tried: cutting YouTube audio library tracks onto a lacquer so you can have a listen. Here's a quick taste, with more coming up later. In this video we dive into the groove of cutting lacquer discs, where the sound of every future copy is defined, and discover that much of that vinyl sound comes down to the physics of the process. When I first heard a lacquer disc played, my jaw dropped. I couldn't believe that sound came from a turntable. There was barely any surface noise, and forget about clicks and pops. If you think vinyl sounds better, this video is for you. If you think vinyl or analog in general sucks, well, this video is for you as well. Buckle up as we travel to Supersense in Vienna, where record-cutting engineer Martin walks us through a process that's been more or less unchanged for over 70 years.
I'm Martin. I'm working as a record-cutting engineer. I've been cutting records for 7 years now. I had the chance to gather quite some experience, and I'm cutting the grooves with these machines here.
Before we discover all about record cutting, please take a moment to like this video and subscribe. It really helps. Technostalgism is a passion project, and I'd love to be able to tell more stories like this and showcase the best gear from the past. Patreon and Buy Me a Coffee are linked below if you'd like to help make this dream come true. Thank you for your consideration. Well then, what does it take to transform music into a groove? At the heart of it is a machine called cutting lathe. This is the Neumann AM32B Master Stereo Disc Recording Lathe from 1958. It literally cuts a continuous wiggly spiral into the blank lacquer disc. These kinds of machines are responsible for some of the best records ever pressed and are still used today. The vast majority of vinyl records start out with a blank lacquer disc. Its aluminum base is covered with a lacquer similar to not quite fully hardened nail polish. Seems trivial, but to achieve the quality needed for hi-fi records is nothing but. It's so difficult, in fact, that there's only one company in the world, MDC, who still produces them in Japan. Before starting the process, a protective sheet is placed onto the platter underneath the lacquer disc. Then, the suction pump tube is lowered, as the machine will keep the disc tightly sucked against its surface.
The first part we have to get moving is the turntable. This is an old motor from the 1950s, and it synchronizes with mains frequency. It doesn't know how to start by itself, so I have to help it a little bit. Now it's already running at the correct speed.
And what's really impressive is that the turntable and the motor are completely isolated from each other via an oil-filled coupling to avoid any rumble or flutter from being transmitted. The turntable is driven solely by a film of oil between the walls of two concentric cylinders. Almost a pint or half a liter of oil goes into the coupling. Wow. Next, the carriage holding the cutting head needs to be moved into the start position, and the spindle lock is engaged. From now on, movement is taken over by this computer-controlled motor. And this is important because the carriage doesn't move at constant speed. Why? Well, because the spacing of the spiral groove varies from one revolution to the next. The width and depth of the groove is proportional to the audio being cut. Bass cuts deeper and louder passages are wider. On the other hand, we want to maximize playing time, so ideally the cutter head is moved just enough to account for the groove width at any given moment. The goal is to pack grooves as tightly as possible while making sure they don't overlap. Now, the cutting head can't just suddenly jump to account for these variations, or can it? Nope. So what the computer does is calculate the speed of the carriage movement to make sure it's always in the right place. And in order to do that, it needs to know what the signal is going to be in advance. With digital sources, it's quite easy to send out a time-delayed signal. But how do you do this when playing back from a reel-to-reel machine, as Supersense do for their Master Cut records, from analog master tape? The solution is as elegant as it's ingenious. This high-end Studer A80 master recorder, well, what's wrong with this picture? This recorder can't record at all. It was modified for cutting records. Instead of having a playback and a recording head, it features two playback heads placed at different points of the tape path. The first playback head sends the preview signal to the computer, so it can determine the groove width and adjust the carriage speed accordingly. And the second playback head sends the audio to the amplifiers for the cutting head. The time it takes for the tape to travel from the first to the second playback head corresponds in this setup to half a revolution of the platter at 33 1/3 RPM. And if we want to cut at 45 RPM, the tape path between the heads is shortened by simply moving the tape from the top to the bottom roller here. This whole process happens continuously in real time to achieve the best possible quality and efficient surface area use. The computer has a few more controls, among which the track mark button, used to manually speed up the carriage between tracks, creating that visible space on a record that helps us drop the needle at the beginning of a track. Now let's also have a look at this rack. It's an integral part of the Neumann system, packed with amplifiers, transformers and signal processors. On the bottom here we've got separate power supplies for the left and the right channel. Moving up, we've got the audio processors with filters and limiters applied just in case the signal needs to be adjusted before being sent to the amplifiers. The RIA curve is also applied at this stage. The 100-watt amplifiers power the cutting head transducers, which are pretty much loudspeakers, one for the left and one for the right channel. Placed at a 90-degree angle and rotated by 45 degrees, the movement is mechanically combined into the up-down left-right motion of the sapphire stylus cutting the groove. A thin wire is wound around the stylus and, as current flows through it, it's heating the stylus to about 200 to 300 degrees Celsius. The heat makes the stylus cut through lacquer like butter, resulting in very smooth groove walls. And the smoother the walls, the lower the noise during playback. As the lacquer is cut, the bits that were dug out need to be disposed of immediately. Called the chip, it's sucked through this little tube behind the stylus and ends up in a glass container. I loved how Martin referred to this.
I will need to throw away all this precious music,
as it's the exact negative of the groove that was cut out. So, over to Martin and let's get cutting.
On a Neumann machine I have to find the start position by hand. I'm moving here to approximately 1 millimeter before the edge of the record. Then I'm engaging the spindle lock here, which means switching between manual operation when it's on the back and computer controlled operation with the motor when it's on the front. I'm moving forward the carriage in little steps using the button that makes the track marks. I'm 2 millimeters inside of the outer edge. I can lower the cutter head. This is actually a security mechanism here. When something happens during cutting, then I have this button and it stops cutting immediately, and it also switches off the amplifiers. I'm lowering the cutter head. I'm not cutting yet. The computer keeps the cutter head 1-2 millimeters above the surface. I must check, and that seems to be good. Mechanically everything is in place. Now I need to engage the amplifiers. These two red lights have gone off, which means amplifiers are engaged, and if music is coming then the stylus will be vibrating. Things have to happen quickly now. I'm turning on stylus heating, then I start cutting. I press a button to make the lead-in groove, which moves the carriage a little faster for a few seconds. The lead-in groove has finished and I'm starting the tape machine and music is coming. I have to take a look whether the chip is properly being sucked away. Looks good. Sometimes it doesn't work, then we have a problem and I have to switch off immediately because of the stylus heating, but mostly it works. At around 8 minutes I'm going to have to press the button for the track mark. And I listen to the noise from the tape. Now I'm pressing. When I create the track mark, there happens nothing more than just 1 second of a little faster movement of this motor here, which moves the carriage. The groove itself is completely uninterrupted. There's only one groove on every side of the record. When you have a live concert, you know, people might be clapping and I might press the button to make the track mark and the clapping would go on during the track mark.
Are we done?
Yeah. So quite much is happening here, but I think this should still be playable very well. The groove might be too extreme at some point, so we are lucky guys today. You mainly see the bass and the high frequencies. Those tiny wiggles on the edge here are the mid and high frequencies. You can also imagine how the stylus is moving up and down, because a wide groove means it goes deep down and a narrow groove means it is high up.
It takes years of practice and experience to know how to cut a record quickly and without issues. And wouldn't it be cool to listen to what playing back a Lacquer disc sounds like? Well, because we can't play back any official Master Cut records on YouTube, we've done something I don't think anyone else has ever done. We've put YouTube audio library tracks onto a record so you can have a listen. The entire process of cutting from digital files will be covered in depth in another video, comparing it to the digital source and tape recording, so make sure you're subscribed. To become vinyl LPs, the Lacquer discs are silvered, electroplated, and turned into a series of metal fathers and mothers used to create the stamper. At the pressing plant, these stampers squeeze hot pucks of polyvinyl chloride and turn them into groovy discs. And so that wavy spiral becomes music again the moment a needle drops into it. Since you've made it this far, here are a few stray observations. First, you're awesome, and thank you. My jaw still drops every time I hear a Lacquer disc played back. It's just uncanny how much better a tape copied to Lacquer sounds than a subsequent tape copy, and I say this as a firm tape lover. The noise floor is simply lower, there's almost no surface noise either. Also, clicks and pops are very rare. And because the aluminum base is rigid, Lacquer discs don't warp and lay perfectly flat on the turntable. You can observe how little the arm and cartridge move up and down even in this close-up shot. The spindle hole is also perfectly sized and centered. What doesn't come across on screen is the smell. Lacquer discs really smell like fresh drying paint. You know those LPs with shorter per side runtime, even at 33 RPM, marketed as higher quality? Cutting shorter sides lets the engineer space grooves further apart and carve a stronger signal into the record, which improves signal to noise. The closer the needle gets to the center, the slower the groove moves under it. A 12-inch LP starts at roughly 20 inches per second on the outside and drops to about 8.5 on the inside. The reduced headroom translates to increased distortion and treble that's harder to keep clean. So, track order is sometimes a technical choice. Comparing this analog penalty to a digital sampling rate drop is misleading. A fairer comparison would be to reel tape, going from 7.5 to 3.75 inches per second. Vinyl versions of the same music sound different because you can't just dump all that digital information into the groove. So you're always essentially listening to a remaster. If that's better, let me know in the comments what you think. Witnessing this process firsthand was such a blast. Now every time I play a record, I imagine the engineer who lovingly cuts the grooves, and that makes me enjoy it even more. I'm grateful to everyone who keeps this craft alive, because the sound of any LP is defined during mixing and cutting. Everything afterwards is just a copy. To everyone involved in making vinyl LPs, thank you. Special thanks to Martin for sharing his process with us, and Doug, Cornelius, Emma, and the whole Supersense team who we'll talk to about Master Cut records in the next video. Stay tuned. Creating this video involved considerable effort, and this isn't a sponsored video. I've traveled at my own expense to Vienna, and Supersense have kindly provided the opportunity to film this series and gifted me the Master Cut record I need to be able to make these videos. If this one cuts straight into your groove, give it a thumbs up and subscribe to Technostalgism. Patreon members have access to early cuts, additional footage, and the full uncompressed comparison audio files. Buy me a coffee and the Technostalgism store with original, no AI, retro-inspired designs are all linked below. Thanks for tagging along Nostalgia Lane.